This is the key to even numbers from section 2.6, page 104. Number 2, we have the equation f of x is equal to 8 if x is less than -1, 2x if x is between the first equation is y equals 8, which is a horizontal line at 8. The second is 2x plus 0. The restrictions are between -1 and 4. And the second equation is -x minus 4. And the restriction is greater than 4. So if you notice, it was only to the right of 4 that we would graph. Erase all the points to the left. Number 14, as you see, it took a little while to get this graph to work. But the very first graph is 2x plus 2, and the restriction is less than 6, which is to the left of. So everything to the right of 6 we erase. The second graph is x, which is the same thing as y equals 1x plus 0. So it's 0, 0, and the slope is up 1 over 1, or down 1, backwards 1, and the restriction is between -6 and 2, and it's a closed circle. The third equation is y equals -3, which is a horizontal line at -3, and the restriction is greater than 2, so everything to the right of 2 we graph, and that was the graph in purple. Number 46, we're solving for x, and this is an SAT problem, so in step 3 is when their mistake was made. Number 48, when is f of -1/2 not equal to -1? And it's at B. Day 2 of section 2.6. This is number 4. We have to come up with the equations of the line. The very first equation is a horizontal line at 6. The second equation, the slope is -1 and it goes through the point -2, 6. So you plug it into the slope-intercept form and you get -x plus 4. In the second equation, you can tell that the slope is up 1 over 2, and your y-intercept is at 2. And the restriction is everything to the right of -2. Number 8, its absolute value of -3x. So your slope is, absolute value of -3 is 3, so your slope is 3 over 1. So on each side of your absolute value, you go up 3 over 1. Or on the left side, you would go up 3 backwards 1. You can pick points, random points. I picked -2, 6, and plugged it in, and sure enough, it worked. So another way of doing this is making tables if you don't really like plotting. The domain is negative infinity to positive infinity. The range is 0 to positive infinity. Number 10, absolute value of x plus 4. That is a shift left 4 places. And then the slope is up 1 over 1. So it's a standard absolute value equation. The domain is negative infinity to positive infinity, and the range is 0 to positive infinity. The very first is a horizontal line at -9. The second, the slope is up 1 over 1. Notice they're counting by 2's. So if you go up 2 over 2, it's a 1. And then the third equation is also 1, and it goes to the point 0.74. So I plugged it into the slope-intercept form to come up with x minus 3. It's a little challenging seeing these graphs in the book, and it was definitely just as challenging to write it on this graph. Number 24, f of x is equal to absolute value of x minus 5. That is a shift to the right. Domain is negative infinity to positive infinity. The range is 0 to infinity. And number 26, the slope is 2 over 1, and it goes down to 8. And if you want to pick some random points, I picked -4, plugged it in, and sure enough I got 0. So you could either make a table or you can sketch it on your own by doing your rise over run for each leg.